So, you've seen chemical equations before. You know how to count the atoms in a molecule based off of the subscripts in its molecular formula, and you know what the coefficients before molecular formula mean. Today, we're just going to put all of that together and try to solve the puzzle of an unbalanced equation. So before we start learning the process, let's discuss the why. Well, a balanced equation is one that shows that there are the same number of atoms on both sides of the equation. To accurately represent a chemical reaction, we must have a balanced chemical equation because the law of conservation of matter says so. The law of conservation of matter says that in any chemical or physical change, matter is neither destroyed nor created. In other words, the number of each type of atom we have on the reactant side, or before the change happens, must be the same as the number of each type of atom we have on the product side, or after the reaction has happened. So, to ensure that we have the same number of each type of atom on both sides of our equation, we have to count our atoms. If you're like me and a rather visual learner, it might help you to draw out the molecules as you're first learning this process. I'm not going to draw them out here, but you will see them at the bottom of your screen for your benefit. Now remember, a molecular formula tells us what's in our molecule. So with our equation, H2 plus O2 gives us H2O. We simply start out with one molecule of each. Now in chemistry we don't write the ones because we don't really need to. The fact that the molecular formula is written there tells us that we have at least one of those molecules, otherwise it wouldn't be written. Even though we don't have those ones written down, we still need to count the atoms. The shortcut to drawing every single one of our molecules is to start out by simply writing the symbols of each of our molecules down below the arrow. In our equation, we have only two elements. We have hydrogen, H, and oxygen, O. Step number 2 is to count out how many atoms of each element we have on the reactant side of the equation. According to our first molecular formula, we have H2, which means there are two hydrogen atoms stuck together. So we start out with 2 atoms of hydrogen. And same for O2, that means there's 2 atoms of oxygen. Next, we count how many atoms of each of those elements are on the product side of our equation. We have H2O, which means there are 2 H's and 1 O. It's very important at this point to remember that we cannot change these little subscripts in our molecular formula. We can only change the coefficients, or the big numbers, beforehand. So step number 4 is to look at our numbers here and see if we have them balanced on both sides. Here we have hydrogen has 2 on the left and 2 on the right. Oxygen has 2 on the left and only 1 on the right. So in step 4, you recognize you have an unbalanced equation and you need to do something to fix that. So we go with the element that needs more atoms of it, and we go with that side. So here we see we only have 1 oxygen on the right, but 2 oxygens on the left. That means we need more oxygens on our reactant side. The only way to get more oxygens is to add an H2O. So instead of 1 up there, we're going to put a 2. Step number 5 is to stop and recount your atoms before you go on. So we only change the coefficient on the product side of the equation. We're only going to recount the product side of the equation. Here we have 2 H2Os, which means that we now have 4 hydrogens and 2 oxygens. Step number 6 is to go back to step 4. Reevaluate our numbers again and see if we need to change coefficients. It looks like our oxygens are 2 and 2, so they're fine, but our hydrogens are 2 and 4. So we need more hydrogens on the left side of the equation. In order to do that, we could add an H2 molecule, now giving us 2 H2. Step number 5, again, is to stop and recount. So we only change the coefficient on the left side this time. That gives us 2 H2s, which makes 4 hydrogens. And we didn't change the oxygens at all, so it just stays 2. Now, step number 6, we go back to step 4, reevaluate. We have 4 and 4 hydrogen and 2 and 2 oxygen. That tells us now that we are completely balanced and this equation is good to go. Let's try that again with another equation. Here we have Na plus H2O gives us NaOH plus H2. So again, step 1 is to write out the symbols of the atoms that you have underneath the arrow. According to our equation, we have sodium, Na, oxygen, O, and hydrogen, H. Step number 2 is to count how many atoms of each element we have on the reactant side. Here we have Na, which gives us simply just one Na. And we have H2O, which would give us 2 H's and 1 O. Step number 3 is to count how many atoms of each element we have on the product side. We have NaOH, which gives us 1 Na and 1 O, and it gives us an H, but we're not going to write that yet because we have an H2 over here. So we have 2 H's here plus 1 H there gives us 3 hydrogens. Step number 4 is to evaluate which one of our elements is not balanced. Right now we have 1 and 1 Na, 1 and 1 O, but then 2 and 3 H's. You'll notice we need more H's on the left side. In order to do that, we have to add an H2O. So instead of 1, we'll put 2 here. Step 5, we stop and recount. So that didn't change our NAs, but it changed our H2O to 2 H2Os, giving us now 4 H's and 2 O's. Step 6, we go back to step 4, reevaluate. Our NAs are still good, but now our O's are messed up. We have 2 on the left and 1 on the right. What molecule can we add to get more O's on the right side? Well, NaOH. So instead of 1, let's make that 2. That now, for step 5, you stop and recount. That now gives us 2 NAs, 2 O's, and 1, 2 H's here, plus those 2 give us 4. Step 6, you want to go back to step 4. Reevaluate again. Our H's are good, 4 and 4. O's are good, 2 and 2, but NAs are 1 and 2. It's a very easy fix. We have Na over here. Instead of 1, let's make that 2, giving us now 2 NAs. So back to step 6. Are we balanced? Yes, we are. One last example before we summarize all of these steps. We have Zn plus HCl gives us ZnCl2 plus H2. Remember, step 1 is to write down all of the elements you have. We have Zn, H, and Cl. Step 2 is to count up the reactant side. We have 1 Zn from here, 1 H from there, and 1 Cl from there. Step 3 is to count up the atoms you have on the product side. We have 1 Zn from here, 2 chlorines from there, and 2 hydrogens from there. Step 4 is to evaluate our numbers and see if we have less of anything on one side than the other. Zn's good to go, but H, we need 1 more on the left side. To get another H, we have to add an HCl. In step 5, we stop and recount. That doesn't change our Zn's, but it does change our H's to 2 and our Cl's to 2. Step 6, we look at this again. Are we balanced? Yes, we are. So as you practice balancing equations with this process, you should be able to do it without a particle diagram to guide you in your counting. So to recap, here are your 6 steps to balancing an equation.